Okay, good morning. With the masterminds, our senior design project is called Material Selection Mechanism. Our advisor is Dr. Basil. I'm Fernando Garcia, Juan Rocha, Magdi Mohammed. Approaching a current problem that a company is having gave us an opportunity to develop our senior design project. The company is called Vinyl Corp, as you see there. It's one of the largest extrusion manufacturers here in the U.S. They make products such as coordinate beads, control joints, veneer products, and insulation systems. We have to come up with a design in order to aid a current recycling process, and we have to take into account that that material has to be categorized by type and size. As you can hear, this is the range of shapes and sizes of the material, the current residue they produce. Some of the challenges we have is all the material built up here that cannot be reused with the contamination with the garden periods. And all those material boxes, which is the recyclable material, need to be moved manually by the operator using cargo carts right now. Some of the main goals we have is to maximize the space facility, lessen the material contamination, eliminate all the material waste, reduce the physical labor and the energy usage. Here's a short video showing how the scraps fall through the punch and die and all the material there. I'm going to leave it with Juan Rocha to explain the motivations.
Our motivation for this project is to design a system that is accurate, is efficient, and is user-friendly, meaning that is safe also. We want to create a system that will improve an undergoing process, which is recycling and sorting. We want to gain professional experience by interacting with engineers and customers. And we want to introduce an innovative prototype to aid in the filtration and sorting process. This is our proposed design. It consists of a collection receptacle, which takes our material into the air conveyor, which works with an air compressor. The flow takes the material to a Y valve and therefore to our rotating drum system filters. Our major components consist of a rotating drum filter, Y selector valve, the pressure regulator, air compressor, and an air conveyor. This is how the air conveyor works. We have an air compressor connected to a point A, and this creates a rush of air through point A and creating a pressure difference between point C and point D. This creates a vacuum which allows us to move the material through the air conveyor into the next stage of our process. This is how the Y valve works. We want to make it automatic, so with the push of a button, the operator can open one valve or close it another one. And this allows us to split the material in two, interior and exterior.
For our cost analysis, we consider two items, which is the component cost and the labor. As you can see, our component cost become $13.80. That includes the real price market right now, except for the rotating drum filter and the Y valve that we're going to manufacture. But we have some estimation for those two. Our labor, the human hours spent is about 195. That include the design, manufacture, and testing. There are some systems around the world for material selection, like a metal separator in Europe or plastic waste recycling machinery in Asia. There are also existing designs to transport the material from one point to another point, such as the vacuum material transport and the auger conveyor machinery. We believe that by some modification in our design, we can help to solve some issue around the world, and by some modification, we can help to solve the world pollution. The two major industries that we can use is the food industry and the recycling process. These are our timeline, and as you can see, by we are right now end of the spring. We are planning to manufacture in the middle of the summer, and so we have enough time to test our prototype in the fall. In conclusion, we're doing the material selection mechanism that can reduce material contamination, can reduce the energy uses, can implement the transport process from one point to another point, and we're hopeful that we can do our prototype worldwide. And thank you for listening us, and we are ready to answer your questions.
Right. And the first question I ask, and I'm just looking at your problem statement, you said that it's a system that will be able to sort for material size, material type, and weight. How is the system going to do that?
Basically, we have two types of materials that go into the drum filtering system, and they have different shapes and different shapes. Basically, there's a large material and there's a small material. Our filter is designed. We want to design it so we can sort out these two types of materials. So it's basically two entirely differently geometries and shapes.
I can show you there more or less the range of sizes that you see here, the small pellets and the big pellets. Here's the chute where they come down from. Well, the sizes for all of them, right? But there's interior material and exterior material. So we have to categorize it by type, which is interior or exterior. They have different properties. That's why we use the wide selection, right? And then the rotating drum filter is going to take charge in sorting by size, I guess by collecting the bigger in the middle of the filter and then allowing just the small particles to fall through and continue to the big part will go to a grinding process, which is here, the grinding station, and the small part which is going to be stored for future use.
I'm looking at your motivation statement here, and there's a complete sentence here, but I'll just read the last part of it. It says, it also deals with several advanced concepts from different fields of engineering, such as structural analysis, transport phenomena, mechanical design, computer-aided design. Who's the advanced structural engineer in the group?
Well, nobody's by the level now, nobody's advanced structural. We meant just, to gain experience in the structural analysis field, which is going to be our material selection, the testing for different properties of each material. I guess that's what we do, that structural.
So are you suggesting then that you need some external assistance from?
We're working with a company with 2 engineers now in the field with the company. Yes, they're going to teach us and guide us through and help us with those structural analysis. That's what we meant by that.
So you will have capability in your team?
Yes.
Okay.
The testing of our system is directed at this company. For example, for the air conveying system, we have determined a few properties, and that's been through experiment in the company.
I have a question. What if you have an external, because you're using the compressor to push the material through the pipe and into your line, and then you have your 2 valves. What's there to stop, say, an external part from trying to enter the internal orifice? You're going into the wrong side.
Well, the compressor that you see here is connected to the air conveyor, which is, this is a collection receptacle. It's attached to the bottom of the chute from the mill.
Okay.
And then just the air compressor just ramming air into here, into this cavity, which is creating suction on this part, and then just rams the air through this is going to be a hose here. It's
Okay.
connected to the white valve, which is, the operator can manually choose which side just to go by the type of material is running currently in the mill.
Well, my question is, what's there to stop from making the wrong component going into the wrong side?
When
Is there a safe catch system?
When the operator puts the extruder device into the punching bags, he has to select whether interior material is being selected or exterior.
Yeah, that's before running.
Resorted.
So
Okay.
when the operator comes to the machine, he has to flip a switch.
Gotcha.
Our idea is for him to flip a switch and decide, okay, interior or exterior, and that's going to actuate the valve. Which way is it going to open and which one is it going to close.
One is closed and one is
One is open, okay, gotcha.
You're going to know prior to running the material.
Okay.
Before
Before
turning
turning them-
supervisor in the mill, just to let him know we're running exterior material, just put it to one side.
Because I was under the impression that you had both of them going through there and it was
Oh
gonna.
no, just one at a time. One at a time to the mill.
Can you guys just quickly discuss the analysis that you're going to do associated with some of the sizes and the flow through each of the different filters?
We have to put, this white valve is a constant, and we have to put it through CFD analysis. And also for the testing of the filter, that's more of a experimental type of testing. because we have to see how the material is going to fall through that mesh. And the way we're going to do this is we're going to place the filter in an angle where we can see how the material is going to tumble through the filter. So the smaller material is going to fall through, and then the bigger one is going to remain in the filter, and that's how it gets separated. But that's more experimental. We have to see how the materials are going to fall through that filter.
That's why we're planning to manufacture in summer, so we have enough time in the fall to test our prototype.
Just by analyzing the range of sizes that the company can have of those pellets, of those knockouts, just by analyzing how big we need to make the mesh, and how, or big or small we need to make. I mean, and we can always, we're thinking of incorporating just time just to add, the capability to add meshes according to future different sizes that the company can use or can create. So we're trying to do that.
Right, the filters themselves can be adjustable, right?
Correct.
So if you
Correct.
adjust the size, you can change that. So as long as you guys keep that in mind.
So, would you anticipate that you can have clogging of those screens? And if you do, how would you eliminate the clog screen?
As far as you mean clogging of the screens on the filter,
Yes.
we have not anticipated there's going to be any clogging involved. Right now, an assumption is, and again, I mean, this is our initial stage, but we assume that the material is going to roll through that filter, and through the circular motion of the filter, the smaller material is going to fall through. And if you could see the pictures of the material, there's a big difference between the big ones and the small ones. So our assumption is that there should not be any problem for the small ones to fall through the mesh, and the big ones to
I mean,
remain.
basically all these are categorized as big pieces that need to be regrinded. I mean, those for sure is going to be our, I mean, we have to make our shape, I guess, maximum to this size, so these fall, all these three fall through, and just keep this inside for them to.
You should definitely be careful about that, yeah. Yeah, of course, sorry.
In the picture there,
I can see that
Yeah.
falling upside down.
Yeah, so say one comes in at a point and gets stuck in there, you know, some of those
Right.
points, yeah. You are rotating that filter, so
Yes.
gravity can't pull them back out, but be careful to kind of triple check on that, yeah, yeah. Yeah, assuming that it doesn't get stuck, right, so
yeah,
Right.
correct.
that
That's
should be a
why
concern,
we
yeah.
have to see how these pieces are going to fall through.
Right.
More questions?
Also think about maintenance too, in your design.
As far as maintenance, the only thing that could go wrong, we assume, is maybe in the Y valve mechanism. The valves might get worn out by the flow of the particles inside. That's the only part that we assume that might need replacement in the future.
Well, I mean, we're doing a small prototype just to show the company the idea of what we're trying to convey here. But I mean, I guess for the transportation from the Y valve to the rotating filter is going to be actually in the company an auger, an auger conveyor system. Due to the facility space, the big space, it's just going to convey that. Because we have to take into account the maintenance of those augers, the maintenance of each of the drum. Make it user-friendly. Make it, I mean, something goes wrong, just go quick there, stop the system, and be able to fix those problem.
Okay?